The last rule in this section is the Descartes rule. So Descartes is the guy who discovered the Cartesian coordinates. Okay, so he's made a great contribution to the development of algebra and calculus. So uh, these are great discovery. So that a lot of things can be done in the xy coordinates plane. So now, what does this rule say? It says uh, for polynomial with real coefficients, the number of positive real zeros, real, okay, not rational, but real, not complex, but real zeros, is either equal, is either, there is a either or, okay, either or. So either equal to the number of variations in sign of f of x, or less than that number by an even integer. So now let's just use these statements to identify the possible number of positive real zeros. So I'm going to say here's the possible uh, number of uh, positive real zero. So the real one um, will be this. So let's count how many sign changes. So if you look at one positive to positive, no sign change, right? Positive to positive, no sign change. That means how many number of positive real zeros, uh, number of sign changes in f of x is actually equal to 0. Therefore, I would say there's no zero positive real numbers. There's no positive real numbers. And by the way, we should also look at the second statement. It says either equal to this number of sign changes or less than that number by an even integer. So let's find so less this number by even integer, say -2 or -4 or -6. But obviously, these are not applicable because we don't have -2 positive real number of positive real zeros, right? So 0 is the smallest, but I just want to explain what that means. It can be two less by even number. Okay, so this is the we know that no positive real zero for this part A. Let's continue to read the part B. The number of negative real zeros of f is either equal to the number of variations in sign of f of negative x. Therefore, you need to find f of negative x first, or less than that number by an even integer. So now, if using this part A, so the positive of the possible number of negative real zeros are let's look at f of negative x first. So it is negative x squared plus 2 times negative x plus 1, which gives me x squared minus 2x plus 1. So now let's count. This is positive to negative, sign change 1 there, right? From negative to positive, there's another one, so a total of 2 sign changes. 2 sign changes. Therefore, the possible number of negative real zeros is either 2 or less than this number by an even integer, or so subtract this by an even integer, which is 2. So 2 or 0. So the possible number of negative real zero is 2 or 0. If I graph this guy for you, this guy actually looks like this, okay? Looks like this. Looks like this. This is -1. Actually, there are two zeros here, -1. -1 is 0, so there are 2 zeros. The reason you only see one because it touches back. Essentially, -1 repeat twice. That's why it considered as 2 zeros there. So this is the Descartes rule of signs. This is the explanation. I would like you to try this one. Okay, you should try that one.